All right, so this is another video looking at inhomogeneous second-order constant coefficient linear ODEs. We've got this one. Now, instead of doing the whole thing, I'm going to just tell you the solution of the associated homogeneous problem. So that's where we solve y double prime plus y prime minus 2y equals 0. That's the associated homogeneous problem. This is the solution. That lets us move on to just examining the particular part. So remember that we have this hypothesis y equals y homogeneous plus y particular, and then we can look at y particular equals. Here, it's sinusoidal. So we're going to guess a sine plus a cosine. C naught sine t plus C1 cos t. And we'll see why we've got to guess a sine and a cosine in a second. Right? It's not just sine, it's both sine and cosine. When we sub this y into our ODE, the homogeneous part is going to contribute nothing because we're going to get a 0 from the homogeneous term here. So we can omit that and we can just jump straight to yp double prime plus yp prime minus 2yp equals sine t. Okay, so we need yp prime and we need yp double prime. So let's get differentiating. So what happens is, because we differentiate and we've got this y prime term, we pick up a sine as well. Now, or if we just guessed yp was a sine, we wouldn't have a cosine to cancel with, right? We'd pick up this cosine term when from our differentiation, but we wouldn't be able to cancel out. We need that cosine in our guess to ensure that we can actually cancel everything out. Right, stick this into the ODE. All right, now we've got to group up the sine and cosine terms, and then again, like for polynomial right-hand sides, we've got to equate like terms. In this case, our like terms are our sine and our cosine terms. So let's just simplify this a bit first. Let's find all the sine terms. And all the cosine terms. Oop. We're going to introduce the zero cos term because we need to equate cosines with cosine and sines with sines. We can actually simplify this just a little more. Let me just check if I'm correct. Looks all right. Okay, so we equate the sine with the sine and find. And the cosine with the cosine to get these two simultaneous linear equations. This is now just a case of rearranging and solving. Okay. Nope. Try again. Yep. And now obviously then C naught is equal to -3/10. Let me just check. Yup, looks good. Sweet. And now my C1 is associated with my cosine term initially. So there's my guess. And my C naught's associated with my sine. So we can write down our y particular, and then we can add it to our y homogeneous. So let's just write out the complete general solution. Homogeneous part first. Now the particular part. Now let me just make sure I've written that the right way around. Yes, I have. Okay, and here's where I'd substitute in my initial conditions if I had any. But the general solution in this case is the best we can do.